Okay, so today we will talk about structures part 2. So next time we covered what's a structure, and structure is a new type. Structure is a type, and we can define structures with different field and use it. And we cover how to initialize it. We cover how to use array with the structures. We cover how to use structures of arrays. We covered how to use structures in the structures. So, do you have any question? Professor Joe, can we use structures in a function? Or can we just use the structure in the main function? We cannot pass it anywhere. If we can use a function, how can we do? How to do it? How to use it? Of course. You definitely can use structures in function. As do remember what I said, the structures as a new type. So structures is a new type. I keep saying it just because it's so important. The structures is just a new type. So you can pass an integer, you can definitely pass the structures. How to pass it? How you pass the integer to other function. If I have a function here called integer food, and it's take an integer x, and say x equal x plus 1, then return x. How you call food? You say food y, and you have an integer y here equals 0, right? Or maybe you can say y equal food y here. If you want to change the structures, how to do it? You can just easily change the type here, integer, integer, integer. You can say, okay, I have a structure called date. And of course, we need to change here a little bit. The structure date is A31, 2020. Okay, then we pass it. So here we need to say this structure date. And we return a structure date. And this should be not x plus 1 because this is not integer. So we change here a little bit. We say x the months equal x the months plus 1. That's it. Okay, so that's it. So this is something we have. Okay, so you can easily pass your structures into another function. And you can return the structures type back to your caller functions. Okay, so here's a question for you. Do you remember in Java, if you know Java, okay, do you remember in Java, if we don't return it, we don't say this. After you call food, what's the result here? What's the y here? The y here should be, of course, 31, 2020, because we didn't update. And because you changed x the months here, doesn't matter you return or not. The x should be updated to what? In Java. If it's in Java, it should be updated, right? This is wrong. This is incorrect in C program. Again, the C structures is not equal to Java class. So in Java, you can do it. But in C, if you don't get the return value, this will be still A. This is not 9. Okay, why? Remember, I keep saying it. The structure is a new type. It's a new type. It's not object. So what did you do for C, for integer? For integer will be equal to what did you do for the new type. So when you pass an integer, if you have an integer, remember, just ignore this one. If the structure date right now is integer, you pass integer to a food, you change the integer inside a function. Does it change the integer outside a function? The answer is no, right? In Java, it's still no. Primitive type is not be updated. However, if it's an object, it's use reference, so it's changed. In C, the structures similar to integer, it's just a type. So even though there's a member in these structures, you cannot easily update it in a function. You need to provide a return value. Okay, you need to provide a return value. And you also need a variable, you need to update it to your return value. Here's a key. Okay, so keep in mind, structures in C, you can treat it as a type. If you don't understand, if you got confused, try to use integer, try to use character, try to use any type you're familiar with. Try to use it to test what happened. Then it will be the same for structures. Here's the key, okay? So this is how you manipulate, how you work with these structures. Do you have any questions? Or, yeah, do you have any questions? Hello, Joe. Can you give me more detailed explanation of what is happened? Why it cannot update the structure? Why it only can update the value if we return it? I don't understand. I think it's a little bit too complicated. Okay, I think this is an interesting question, and let's talk about the memory model for this C language support, because the memory management by C is very special for the structures. So here's the memory we have, okay? And if we define, for example, we define integer x, so our compiler, our memories, our systems will give this integer the memory stuff here. So the value should be here. If we say x equal to 4, then it's set for this memory address. Okay, so when you pass x into food, for example, you pass x equal to food, what did you do? It does not pass the address of a variable. It passes a value. So that's what we said call by value. Okay, so because we try to pass the x, we just say food x. We try to pass the x into food. So we imagine that this x, this area is detected by the function, right? But it's not. The systems, how system to do it? The system say, okay, right now you call this function by using this variable, so I get the value of a variable, store it to another place. So actually, there's another place in the memory. I try to copy this value 4 into this memory address. And this memory address for a special variable, this variable is called x, still x. But this x is belong food. So we can say it's a food.x. And this one is main.x. Both variable called x, but they are different. Copy the value of the x in main function to the x value, the variable in food function. Then if you update the food here, you try to update here, you update 4 equal to 5. But you didn't update this, right? Oh, this is return x. You didn't return this. So this is why you only got updated in the function. It did not update anything outside the function. This is called call by value. And in C, it's use call by value to support everything, including the structures stuff. Okay, so let's go to another example. If I have a structures, how our memory system to do it? I say structures date, integer, months, integer, day, integer, year. Okay, how our systems to do it? So when I define the structures, date, today, equal A31, 2020. Okay, when I define in memory, it gets a chunk of memory. Okay, and this is for today. But actually, it's use the order of your structures. It's use the order. The order is months, day, and year. So it's put months, day, and year. And you can see your data is A here, 31 here, and 2020 here. And this mapping to today, the months, the date, the year. But everything here is for today. So the system understand this is new type. This is new type. How many memory is need to allocate for this type? It will use the information you provide in this definition. So if each integer is 4 bytes, the structured date will be 12 bytes. Okay, it will be 12 bytes. Then you can use this 12 bytes as information to allocate the memory, got this chunk of memory. So when you pass this food today to another function, it will allocate the same information because you know the type. So there's a 12 byte here. It's for a new variable called day one. Then if you pass this number, it copy the value 31, 2020 into this function. Okay, so even though you change the function, change these structures in function, it change the value here. It change the value here. It does not change anything here because the systems copy the value of everything for the structures to another memory location. And no matter how you update, you just update another variable in the function. So you need to get the return value. You need to say today equal the return value. So after you update it, you try to assign this value into this. So you try to assign this back to here to update the original data type. This is a memory model for structures. And these memory model structures, the order is matter. How you define your data. The months go first, the day goes second, year goes third. If you change your order, the value here will be different. For example, if right now I just change the months and day by here, I say this is day, this is months. Okay. If I change the day, month here, I say this is A and this is 71 and A. So it will be 71. In this case, the order will be different. The order will be the order will be 31A. And here, the same, 31A. And you update A to 9. That's it. Okay? So this is a memory model for the structures. And of course, there's more complicated memory models. If I define a structures like this, struct um, X, just a new stuff, and it has integer, it has a character, it has array of integer or character. Let's say character integer X. No, integer A, integer A, and character B is 12 byte, and that's the integer C. Okay, so what's the memory look like for this example? It will be X 4 byte. No, X A. So this is X A 4 byte, and B is 12 byte. So you got this area for B, 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 B. Then C is here. Okay, so the memory based on order is given a location. And if you use array, of course, it's provide every information for array first, then give you another integer. That's the idea. So this is the structure. This is a memory model for structures. And the key for the structures in a function is, remember, call by value. If you get confused, think about how to pass an integer to a function. It will be the same as how you pass the structure to a function. Okay, so today's class is here, and I hope you enjoy it. I hope you understand what the structure is. Structure is really useful, especially we will talk about more complicated data structures in C languages later. Awesome. Structure is